In this video, shape will be discussed. Shape is everywhere in the world, though in mathematics, there are many two-dimensional and three-dimensional, so the classroom's block corner is ideal in helping children explore shapes. Children and teachers can look around their physical classroom and discover that there are endless shapes. However, in mathematics, these are often the ones that share similar attributes and not random blocks. The big ideas for shape are, firstly, shapes are defined and classified by their attributes. Secondly, the flat shapes of three-dimensional shapes are two-dimensional shapes. And thirdly, shapes can be composed or decomposed to create new shapes. Firstly, shapes are defined and classified by their attributes. Shapes have rules that make each shape, such as a triangle having 3 sides or a square with 4 equal sides. So teachers should craft activities that highlight these important rules. Using these rules, it is easy to identify or even create shapes from loose parts. The rules also ensure correction, because though a rectangle and square have the same number of sides, only the square has 4 equal sides. Secondly, the flat shapes of three-dimensional shapes are two-dimensional shapes. Children can explore and discover that two-dimensional shapes are found on the faces of three-dimensional shapes. Concrete materials are great at illustrating this rule, as children rotate common household items like toilet roll cores or box. They can discover there are hidden shapes everywhere. Thirdly, shapes can be composed or decomposed to create new shapes. As children gain opportunities to rotate, combine, and compare shapes, they will realize how shapes have part and whole relationships, where there are shapes within shapes. They can break apart a shape into different shapes, or even use shapes to create a different shape. The possibilities are endless. So what does the role of the teacher look like? There's a wide variety of student profiles in the classroom, so teachers need to cater instruction for all students, such that the different dimensions of diversity are covered, including gender, culture and ethnicity, socioeconomic status, experiences, language, delays or disabilities, and developmental level. The lessons and classroom environment should never be a one-size-fits-all approach, but rather be sensitive to the different learning profiles of children. Teachers understand that manipulatives help children to learn abstract mathematical concepts, but they do not contain mathematics for children to learn, and are only helpful in guiding children into thinking problem solving. And one example to teach shape is using tangrams for spatial reasoning. Though teachers should not help them too much, that causes them to lose opportunities to think, and if a child faces frustration, it is better to provide an easier activity. While concrete materials are often used for illustrative purposes, the main benefit of them is to allow children to self-discover and problem-solve on their own terms. Teachers should think critically about the types of materials found in the classroom and never intervene when unnecessary. Instruction and construction differ in that instruction is classroom practices the teacher carries out to provide knowledge with objectives and systematic systems, whereas construction is about how children learn through a process to actively build their skills and concepts. And in modern classrooms, both exist together. As teachers build a learning environment, children can construct knowledge and problem solve. Thus, the topics and big ideas of mathematics have been elaborated through this series of 6 articles and videos. As always, thank you for watching and I'll see you in the next video.